Hey Tal, thanks for taking over the class. I appreciate you doing that at the last minute. I decided what I'd like to do is rather than doing the entire lesson, was just to focus on a briefer part of it and do a single activity, something that I do every semester. So um, it kind of helps. I did it in high school and then again in college. I think it kind of helps to show what the chi-square test does. But so I have a slightly revised set of slides here where I'm just kind of unpacking a little bit of this original explanation of what a chi-square test is. So I'm just going to explain to them that um, the basic idea behind you know the general chi-square test is that you have some kind of discrete distribution. So the example might be like this, where I have a set of grades, A, B, C, D, and F, and at the beginning of the term, I might decide what percentage I expect. Um, how many, rather the number of counts, the number of A's and B's and so forth that I would expect. And then at the end of the term, I would put down the number that I actually saw. And so the question, that kind of comes natural from this is, are these pretty much the same? And so, the formal test is there a statistically significant difference between this expected distribution and this observed distribution? So that's the chi-square test that I'm just going to focus on in this lesson. And so, we've been doing hypothesis testing, and so they know this idea of null hypotheses and alternative hypotheses. And so with the chi-square test that we're talking about here, the null is that the expected and observed are the same, and the alternative is that they are not the same. Okay, so if you fail to reject, a certain level of confidence, of course, a p-value, then the two distributions are statistically identical. Okay, and so the way this is calculated, so they know all the steps of generating the hypotheses and then deciding on the confidence level and all those various steps of the critical value and the critical value method, the p-value method. But so cutting to the chase, and the calculation of the test statistic is just this, where you each of these, this little O stands for observed, and this E is for expected. And so what we're doing is we're taking for each of these rows, we're taking the observed, subtracting the expected, and then squaring it, and then dividing it by the expected. And then we just add all those up. And then in the end, what you get is a statistic that follows a chi-square distribution with n minus 1 degrees of freedom, where n is the number of rows that you have here. So the number of different values here is 5, so the degrees of freedom is 4. So when you're calculating the p-value, you'll be using degrees of freedom 4 for this problem. Okay, so so I just demonstrate down here how exactly for this problem, this particular statistic is calculated. And so it just shows you piece by piece, and then you add all this up and you get something. So I've also, if we can just do it in Excel, so we could just paste these values into Excel. Actually, let me do it this way. Okay, and then okay, so this is the grade, this is the expected, and this is the observed. I'm going to make these normal so I can look at them. Okay, so, sorry, observed. So, they know how to, calculate things on the spreadsheet, just kind of going piece by piece. So if we're going to do this, and a lot of times I have them do this along with me so that they can do it themselves independently when the time comes. So what I would do is for each of these rows, just put this figure right here. So in this case, it would be the observed minus the expected squared divided by the expected. Okay, and we can just drag that down so it's like that. Remove the number of decimal places. Okay, so All right, so the copying and pasting seemed to work. So down here, all we do is, so once we have all of these different figures, we can just add all of them up. So it'd just be a sum of all these, or they can be auto sum, and we get this. So this is actually our chi-square statistic. And so as always, after we calculate the test statistic, we need to know what the p-value of that is. So the probability of observing a value this extreme if the null hypothesis is true. And so in this case, so back here, the chi-square distribution looks a lot like the F distribution in that it is always positive. So there's no two-tailed test kind of thing here. It's just we're interested in the amount of area to the right of the statistic that we've observed. So we're going to do the 1 minus thing that we've been doing. So because the total area under this curve is 1, we're going to do 1 minus this area, which is going to be using the Excel chi-square disk. So we're going to do equals 1 minus chi-square disk. Okay, and then the x is the test statistic that we calculated. Degrees of freedom, okay, so we got 5 values. Degrees of freedom is 4, and we always put true here for this. Okay, so that's calculating the p-value. Okay, so we've got a lot of decimal places here. Okay, so there's our p-value. So if we took a confidence level of 95%, this is a fail to reject, which means that the two distributions are pretty much the same. Okay, so that's the formal execution of the hypothesis test for the the chi-square test for identical distributions. Okay, so and this slide just kind of summarizes what the spreadsheet did. So the activity then that I had planned for this is involves testing whether the observed distribution in M&Ms matches what the distribution as reported on the Mars website. And so I actually did do this. This is, according to Mars, this is the distribution of the colors that you would have in a typical bag. So what we want to do then is collect data so that we can test whether this theoretical distribution is identical to what we have observed. So I've got a bag of M&Ms for everybody. So what you can do is just on the front desk there, you can set up a spreadsheet just like this. So this will be the bag number. And one by one, the students can just come up. There's usually just kind of, this is time for milling around, and as they do their counts, they can come up and do it. But each student is going to get a bag, or 2 if there's any left over, and they're just going to count how many of each color are in there. And so, they'll come up and let's say, they're the third person, and they've got 2 of these, and 3 of these, and 4 of these, and so they'll just fill in. So by the end of the class, you'll have, I think that class doesn't have a whole lot of people in it, maybe 20 rows. Okay, so then in order to convert this into data that we can do the chi-square test on, so we have to have our observed, and expected. Okay, so there will just be one, so you can do this test in front of them. So what we'll do here is just column-wise take the averages. Okay, so the average number of blues, and just for each color we'll take the average, and that will be that'll be our observed. Okay, don't like having so many decimal places. Okay. And so in order to find expected, we have to know, the total number that we had. So we would have to do like a, sum the number in each bag, and then at the end, just take the grand sum of the, so the total number that we had. So there were 39 in all here in my imagined scenario. So that would mean that the expected would come from this distribution here. So we would expect, we would expect 24% of them to be blue. So the expected would be 0.24 times this total here. Okay, so 39. And then this would be 0.14 times the total. This would be 0.15. This 15% would be green times the total. 0.2 times the total. 13% red, so 0.13. 0.13 times that. And yellow is 0.14 times that. Okay, so then we have our expected values. So now all we have to do is make these figures again, where we're doing the difference between the observed and expected squared divided by expected. So it's just going to be, so to be observed minus expected squared divided by expected. Okay, and then we can just copy and paste that over. And then once we add all these up, just be the sum of all these. So we're just implementing that. And so we wind up, this is our test statistic. Now I've completely made all this up. I'm just kind of showing how you might do this. So then we would just need the p-value for that. And so that's going to be 1 minus chi-squared distribution. We put in our value. Degrees of freedom here, we got 1, 2, 3, 4, 5, 6 colors. So it would be 5 degrees of freedom, and then we always put true there. Okay, so we have a p-value of 0.002. So this would be a reject. Okay, so this would mean the observed is not the same as expected. Okay, so I think that's that's not a terribly long lesson, but it introduces the idea that the chi-square test is really about comparing what you expect from what you actually observe. And so this is going to lead into what I guess I'll cover next time, which is just that there's going to be one way to get this observed versus expected is to test whether two categorical variables are independent, because there's a certain thing that you would expect if they are independent, so you would look at observed minus expected and so on and so forth. But I think that the M&M thing is a nice short lesson. Okay, well, let me know what you think. That's going to work, and hopefully we can talk some tomorrow.